So as I was saying, um, you have your first three Newton's laws, which is the first one, where an object will stay in constant motion unless if an external force is applied on it. You have your second one, where they relate that external force to the acceleration, where when that external force is applied on the object is going to accelerate. And that acceleration is directly proportional to the force and inversely proportional to the mass of the object. And you have the third one, which is when body A applies a force on body B will apply a force of the same magnitude in the opposite direction of the force of body A. So those are your three basic Newton's laws. Now there's this other one, which is Newton's law of universal gravitation. So I'm just gonna teach you this so that when your teacher comes up to this chapter, because I think you guys are no longer okay. Can you hear me? Because they keep saying like it changed now.
Yes, I can hear you.
Okay. So with Newton's law of universal gravitation, it states that every particle applies a force of attraction on every other particle, and that force is directly proportional to the product of the masses of those two particles and inversely proportional to the squared distance between those two particles. So what that means is that you're gonna have your F, which is your force, is equal to your gravitational constant. This is just a number for universal gravitation. So this number is 6 point, I think, 062. Um, let me just open this up. 06. Nah, it's 6.62. And that's all going to be multiplied by 10 to the exponent negative 90. And this is going to be directly, since the force is directly proportional to the product of masses, you're going to have the mass of particle 1 and the mass of particle 2. And this is going to be divided by the squared distance. So distance squared. So G is a constant. That means every time when you're going to substitute, you know that G will not change. And this is the mass of the first particle multiplied by the mass of the second particle. And this is the squared distance in between. So basically, we went through a few questions, Jason and I. Actually, there wasn't even that many questions. There wasn't even that many questions. So I think we went through like one question. And then after that, we agreed that we're just gonna meet today and we're gonna start with the actual questions. So this is the formula that we're gonna use for Newton's law of universal gravitation. this chapter has fairly lower marks as compared to the actual Newton's laws, because I think usually it's gonna be like a 6, 7 mark question. Yeah, 6, 7, 8 mark question. And then yeah. So there's also this other way. Let's just leave that one out for now. So yeah, so this is basically the formula that we're gonna use today, and the formula that we're gonna use every time when we're using Newton's law of universal gravitation. So Kyle, do you have any questions on this?
No.
Oh, no. Okay. So then I'm just gonna get into it. So yeah, let's go. Let me just share this. So, Jason, I saw your question. You're just gonna first do this one, and then we're gonna go into that one. Yeah?
Yes, sir.
Okay. So, the very first question that I have for you right now is, can you differentiate between mass and weight?
Sir.
Mass is a unit of measurement of weight, and then
Sir.
weight is weight, sir.
Sorry, sorry. One at a time. At a time, please. Okay, let's say this, huh? Jason, you go first, and then Kyle goes after.
Okay, so mass is a unit measurement of weight, and weight um is the total mass.
Okay?
So,
Yeah.
so is mass the total the amount of particles in an object, and weight is the gravity. Oh,
Weight is
it's
the
so
like you
isn't
you're on the right path. You're on the right path. You just have to like go.
I say I'm not sure about the weight.
Ah, man, you're on the right path. I'm telling you. You're
So
you're you're so
know
close.
I know it has to do with gravity, but I don't know how to explain. I
Okay.
don't understand. I don't know how to put it in words.
Okay, so between mass and weight, which one is a vector and which one is a scalar?
So are they? You say is weight the vector?
Yes, weight is the vector, and then mass is gonna be a scalar. So I'm gonna explain this now. So if you look at it, as you said, mass is like basically the amount of particles that are in an object. Né? That is a perfect explanation. Like I couldn't have done better myself. So if you look at it, you always see the mass, it's in kilograms. It and the mass doesn't have a direction. No? So the mass is sort of like it's a scalar. So when you're actually like stepping on a scale, you don't see your weight. You see your mass. But since like, we're so used to like saying this is how much I weigh, you know, when you step on the scale, you see your mass and not your weight. And then weight is the force, is the gravitational force on that on that object. You see? So your mass, your mass is what you see on the scale, and your weight is what you apply on the scale. Because same time you step on the scale, let's say this is a scale, this is you, you're stepping on it. So this scale, it's gonna feel your weight and it's gonna push up on you, no? So same time it feels your weight, it's programmed to convert that weight into mass. So you see how much you weigh. So basically what you see on the scale, that's your mass. And then what the scale feels is your weight. If you're gonna see like your weight on the scale, it wouldn't be in kilograms, it was gonna be in newtons because it's a force and your weight is always going down. So yeah, so basically weight is the gravitational force on the object. Yeah? And mass is the amount of particles in that object. So now we're gonna say state Newton's law of universal gravitation in words. Jason, can you state that for me? Just want to make sure that you still remember.
So every mass that attracts another force is directly proportional to the product of the mass, and inversely proportional to the square distance between the centers of the mass.
So if you say inversely and indirectly, that's the same thing. That's literally the same thing. There's no need for you to change it. It's indirectly proportional or inversely proportional. So I just hope that you understand that. Anyway, so that question is here. Explain the difference between weight and mass. It was there in the question paper, and you're most likely gonna encounter it. Oh, did I stop sharing? Uh, so let me just place that there. So, and then, so they say the gravitational force on a probe called Curiosity on the surface of Mars is 3.38 newtons. The radius of Mars is 3,390 kilometers, and the mass of the planet is given. They want you to calculate the mass of the probe. So if you remember from our equation, F is equal to G M1 M2 divided by d squared. So since we're talking about from the center of mass to this object, we're gonna say we're gonna change this to make at least one of these masses the subject of the formula. So that means on this side, what we're gonna do is that we're gonna multiply by d squared in order to eliminate this d squared here, and divide by g in order to eliminate this g. And then if you want, you can also divide by m1 or m2. I'm gonna make the mass of mass m2. So we're also gonna divide by m2 to take this out. So we're gonna end up with this cutting, this also, and this also. And then on this side, we're also gonna do the same, because what you do on the right, you have to do on the left. D squared divided by G m2. And these are all gonna cancel out. So you're gonna end up with m1 is equal to this multiplied by this f d squared divided by g m2. So just give me a few seconds while I get my calculator out. Oh, do you have your calculators nearby? This thing. So what is the thing? So what I want you to do is that you're gonna substitute these units into this. So we have the mass, we have the force. We're gonna substitute that as F. We have the mass of mass. We're gonna substitute that as F2. We have the radius. That's gonna be our d squared. And G is given. It's gonna be given in your question paper. Here's the value of G. Times 6.67 times 10 to the exponent -11. So let me just substitute that. I think these headphones are dying. I need to get a new one. But can you hear me?
Sure.
Yes, sir.
Because now it's changing between the external mic and the headphones and stuff like that. So I'm not sure. But anyway, you can just substitute all those onto this and see if we get the same answers. Because I've seen it, like sometimes you guys have an issue when it comes to substituting. So can you just please do that from your side, and then I can know whether a substitute I can be confident in you guys substituting, or do I still need to help you?
So can you still help us?
In just substituting.
Yes, sir.
Okay. Um what mass did you get when you did this? Because I'm getting such a small number that it's hard for me to believe it. But if it's what I get, I don't know. There's nothing I can do about it. So what answer did you get when you're like substituting? So what you're gonna do is that when you substitute, yeah, I think where you're gonna have an issue is with this d squared, but I'll help you with that. So it's gonna be, let me just write this down in text. Oh, yeah, it's gonna be open brackets. Um, should I erase this?
I got 9,03 times 10 to the power of -4.
Yeah, that's what I keep getting. But it can be something like this. Three. Why is there so much stuff on my screen right now? It's gonna be something like this. Three. Oh, sorry. And then all of this 3390, it's gonna be to the exponent of 2. So this is basically just shows that it's going to be like here when I use this arrow. This is all gonna be divided by all this. Times 10 to the exponent of 23. And then you're gonna have your mass, your 6.67 times 10 to the exponent -11. So were you able to get this far? Sorry, Jason, is this the way that you did it?
Yes, sir.
And what's your answer?
9,03 times 10 to the power of -4.
Oh, bro, is my calculator faulty? Because I get 8.596 times 10 to the exponent -4. What's wrong with this calculator now? Or is it yours? Ah,
Also,
okay, let me just try to reset this. Uh,
So,
yes.
so what is the value of the G?
6.67 times 10 to the exponent
power of
-11.
-11.
Yeah.
That's the
Okay,
one.
okay.
Let me just check because I'm not sure if this whether uh, let me check this. Let's cancel this. Gravitational. Yeah, it is times 10 to the exponent -11. So let me try to calculate this again because I don't know whether it's my calculator. Squared 6.63 times 10 to the exponent 23. 6.67 times 10 to the exponent. Uh, uh, now I'm getting 8.6 times 10 to the exponent -4. Do you hear me, Jason?
Yes, sir.
Now I'm getting 8.6. I don't know whether it's my calculator or not because that time I was getting 8.5. Now I'm getting 8.6.
Yeah, did you put the times like in the calculator and then put the square and the values by each like
Yeah, yeah,
the values being squared and so on?
yeah. I just put them in as they are, man. Uh, so I don't know whether should we take mine or should we take yours. Can you
Then
try?
calculate it quickly. We can take Kyle's answer, so
Sorry,
you can calculate it quickly.
try to calculate it from your side, but I'm getting this. Kyle, can you calculate this because I don't know whether my calculator is off or what's happening.
So I got a different answer.
What's your answer?
So I got 9.00 times 10 to the -4.
Yeah, that's what I got, sir. Me and Kyle have the same answer.
Mm, okay, let me just write how you're gonna substitute, yeah? And then we'll see whether you substituting right, yeah? Uh, okay, because because if you are substituting right, then that means my calculator has a problem. So let's let's get this. You're gonna have m is equal to this multiplied by this. So we're gonna have 3, 3, 3, 8 newtons. And this is gonna be multiplied by the distance squared, which is gonna give me 3, 3, 9, 0. Yeah, this is why. Oh yeah, I'm sorry. I'm sorry. So what I did wrong is that I just saw why this number is so small. So basically, you know that in physics we're gonna use our SI units, and then the SI unit for distance is not kilometers, it's meters. So firstly, we're gonna convert this into meters. So this is gonna be 90 times 10 to the exponent 3. But that doesn't change much because we're still gonna end up with the same question. And then this is all gonna be squared. Only this part is squared. Then we're gonna divide by 6.67, which is our gravitational constant. How much time do we have now? Uh, less than a minute. I won't be able to finish this. Let me just end this. We'll start a new one and finish this now quickly, yeah?